Welcome to Maintainable, the podcast where we explore the art and sometimes the mess of software that lasts. I'm your host, Robby Russell. On this episode, I'm joined by Lucas Roesler, head of engineering at Contiamo. Lucas has spent more than 12 years working professionally in the software industry, and closer to 20 when you include his early experiments with open source and the early web. In our conversation, we'll unpack what simplicity really means in practice, why fast feedback loops can make or break a system, working in the client services world versus a product team, open telemetry, navigating a project that has had thousands of database tables, views, stored procedures, and helping modernize it, and much more. Lucas joins us from Berlin, Germany. Lucas Roesler, welcome to Maintainable.
Hey, thanks for having me.
So given your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I think the list, people could probably make an infinite list, but I think the one that stands out the most to me is being able to read that software from the beginning. You spend so much time doing that, whether it's reviewing code or starting a new project or jumping into an old project, and having the ability to look at that code and have some intuition about it. That makes a big difference in being able to then do anything else you want, whether that's ship the code or change the code.
I'm curious if there's some, say, tangible examples that you would kind of expect to see. Is it just that you can read through it, you know where to find things? You mentioned being intuitive a bit. Are there some artifacts that you're like?
Yeah. There's definitely some stuff in my own projects or the projects where I'm collaborating with that I'll usually push pretty hard for. And these can sometimes go into, or maybe even be classified under other topics or concerns. But I think the obvious one, especially with GitHub, ever since it introduced the README as the main entry point to a project, this should be pretty accessible. And give me some sort of guidance, probably from both perspectives of what do I do if I want to play or run with this software, ship this somewhere, or if I want to make some changes, where should I start? So I usually want something like that in the README. And then in my own projects especially, there's certain things that I really like. For example, all the configuration being in one place. We do a lot of Python, so I like having a file called config or configuration, and there's not a single other os.environ or git value or any of these sort of things. I want them, when it can make sense, there might be some exceptions, but when possible, put it there, because then I can just go and see everything. Python, I also have a background with Go, so there, having a main.go is really common, but that's not necessarily the case in every language. But sometimes it's nice to be able to find something that's obvious, this is the main entry point. So you'll find that sometimes in some of my Python projects where there's a main.py to try and make it obvious, hey, look here first. Hopefully this is then you kind of follow that trail to whatever else you're looking for.
Are there any things that you would indicate? You mentioned READMEs, main files, things of that nature, but are there any things that you tend to have been exposed to that are missing and then maybe those systems are falling short?
In terms of readability specifically, or in more broadly?
In more broad terms, yeah, for sure.
Because I think readability is a bit trickier to kind of be this was missing or not. It's one of those the things that kind of, it's not great, but you kind of know it when you see it sometimes. There's something this isn't very clear. One of the things that I think is maybe missing in a lot of projects, and hopefully no one goes looking through my back catalog of projects as well, because sometimes it's an aspiration to have pretty good observability to go along with that. So I guess you could say that this is a readability, but at runtime in some sense, what did this application just do? Why did it do this? What was going on when it did this? So when tracing kind of, I don't know when that really became popular, but you had things like Jaeger, I think came out of Uber. And then you have things like open telemetry now, which are trying to push all this forward and kind of standardize it, which is great that it's standardizing. It makes it a lot more accessible, but it's probably not in most projects. And I think makes a big difference for if there's a project that has it and you can turn it on, and it just immediately makes it so much more understandable what just went wrong. And, hopefully giving you a chance to reproduce without needing to ship everything and recreate the beginning of the universe in order to get back to wherever state that it was in. You can be I can just look at the history and see that.
Yeah, we'll definitely come back to this topic around observability in a little bit. And I'm curious to provide a little bit more context for our listeners. Now, I know that you've spent a large part of your career, say, in different engineering and leadership roles. So what experiences have played, like from your perspective, played the biggest part in shaping how you think about maintainability today? And maybe more specifically, has your perspective changed as how you think about like maintainability as you've taken on more like a leadership role?
I don't know if it's necessarily as my birthday is coming up. So maybe I'm confusing aging with responsibility and leadership because sometimes these things go hand in hand. But I feel that the biggest thing that has changed from when I was younger, and this might be something that's almost a meme at this point, is when you're younger, you're more interested in kind of like proving yourself, building things, which sometimes means like building lots of things. And now I'm much more interested in building just the right amount, trying to simplify things to the right level. Obviously there's a extreme version of simplification where it just doesn't function or it doesn't support the requirements, or the use case. But I think that's the biggest thing that I've become much pickier on. I remember being, so I was for quite a while one of the maintainers of OpenFast, which was a functions as a service open source solution. So if you've ever used AWS Lambda, then you know kind of what OpenFast is sort of about, doing Lambda, but open source. And obviously when you're doing functions as a service, you can argue, oh, well, it's really simple. Like the single function, it should be hopefully simple, but you also end up with sometimes quite complex systems. And in some like recent projects now, not that I'm going monolith or anything like that, but they definitely feel quite different than the projects I was building then, simply due to, I think, a little bit of myself. Maybe there's some context to those projects as well. It's hard sometimes to decouple everything, but I definitely feel that it's a pattern now where I'm like, okay, do we really need to split that into two? Can we put those things together? I spend a lot of times in the DevOps world and I'm doing more and more of that. So maybe that's something that's changed recently, where if I can merge two things together without creating a lot of technical debt, I like having, the most concrete example is we have applications that will have a small backend and a small front. Do these really need to be two containers, or can I ship them in one container? They're really the same thing from a application perspective, the way people interact with them. So this is something where I might kind of pull them together to make it simpler for the operational perspective. Because for the engineers, it's also not that, it's not really more complicated either. It's not like these big separate services that really have different life cycles. And this is something I maybe would have been more as an engineer when I was younger, being like, no, let's keep these separate. They're different stacks. Container needs to be as small as possible. So I think this is probably the biggest change that I can think of. I don't think it comes necessarily from leadership per se.
That's an interesting topic around, I hadn't planned on digging into this with you, but the proliferation of let's splitting up everything as much as we possibly can. And do you feel like you were around when that sort of shift from like, say, going from more of a monolithic approach to like, let's use a bunch of different services and split these things in different pieces? Do you feel like that was more often a case of how did teams and organizations want to organize the work within their organizations versus these are technical architectural decisions just to keep the containers as small as possible? We can kind of orchestrate it this way as a pattern, and now, but then teams are also then having to be responsible for maintaining these things, and you've got a lot of different services, and you're like, well, we've got this thing, this thing, and this thing. The overall keeping it all in your head is a little bit more challenging when it's like a lot of different things. At least that's my perspective on how that's kind of evolved over the years. But what's your kind of storyline? Where do you feel like you joined the community and then went down that path, and like now you maybe have a different perspective there?
I mean, I can't say I was at the beginning of Docker long term. I originally was an academic and then I switched to tech. But I remember being shown Docker, and there was still quite, like, Docker Compose, I don't think existed. That like happened like a year or two later. So everything was like lots of scripting to try and make this thing work. I think especially with stuff like Docker, it helped kind of push this idea of like, oh, no, we can really just create a small self-contained service. I don't think the concept is, I think the concept kind of predates that, but in my kind of storyline, kind of came in and there were still VMs. We were still doing things with VMs and reaching out to servers. And then like a year or two later, it all switched to Docker because it was the coolest. And it really was a productivity improvement. But everyone was like, this is cool. And I think it kind of like kept pushing that forward. So I think in my specific projects up until about 8 years ago, it was definitely more of this is what's going. It was definitely more a trend, more trendy, more about the way that we were structured. Looking back and being honest about the technology, like I don't know if it needed to be that way necessarily or not. At least at the beginning of some of the companies I worked at. One of them, it kind of definitely evolved in that direction and it made sense. So there, kind of the trend and the engineering went hand in hand, fortunately. So yeah, I feel like I kind of lived through that trendiness of it, and it was definitely part of that. But I tried, and maybe this is now kind of the classic pendulum swings in both directions. So maybe maybe we can merge this together is just the pendulum going back a little bit.
Hey listeners, it's Robby here. It wasn't all that long ago. I'd find myself debugging a weird issue in one of our clients' Rails app. I log into one platform to track down the error, only to realize it was tied to some performance issue. And guess what? That meant hopping over into a completely different tool and trying to match things up based off of timestamps, if I was lucky. And let me tell you, my productivity didn't exactly thank me for that. Enter AppSignal, our podcast sponsor, and the tool that eliminates all that back and forth. They bring error tracking, performance monitoring, host metrics, custom metrics, uptime monitoring, and logging into one seamless platform. It's a single source of truth that helps keep your app running like a well-rehearsed symphony. Whether you're working with Ruby, Elixir, Node, Python, or tracking front-end errors in JavaScript, AppSignal has your back. They're always adding support for more languages and frameworks too. And here's the best part. AppSignal won't break the bank. Plans start at just $23 US a month. Plus, they're ISO 27001 certified and fully GDPR and HIPAA compliant, so your data is safe. Oh, and because you're a loyal Maintainable listener, you can use the promo code Maintainable at checkout for 10% off your first year. So head over to appsignal.com. Tell them that your good friend Robby from Maintainable sent you and start making your app sing. Do you think, if you were kind of like early on in your career, maybe when that was starting, I'm curious if you feel like you recall what might have been setting some of those trends. I always wondered if it was a little bit more of like, well, the people that would speak at the big conferences about this tended to work at much larger organizations dealing with much bigger scaling things. And here's how they solve those problems. And then there's maybe a little bit of optimism by a lot of us engineers. Like, well, if they're doing that, maybe we should do this too, because this will make things easier. So we don't have to have the pains that they did to get to that point. We'll just do this now. I don't know if that, then maybe they kind of, the trade-off was you got some other interesting pains you didn't. There's always a trade-off, right? So that's, I guess, the classic part of the whole thing. Trying to, always the answer is it depends, maybe.
Yeah, I think for a couple projects that I was in, it was just, and I think now this is also true, where because it's so trendy, it's discussed, there's just tools, there's just blogs, there's everything around to support this in that time and moment. You're like, how do I do this? Whereas sometimes looking at something that might be a little older, you run into a lot of blog posts that maybe they're outdated, or there's too many caveats. There's someone talking about all these edge cases, and so it's maybe a little bit harder to get to the punchline or get to the reward in it. So there's kind of, I think that was certainly part of just, it's handy, it's easy to reach for. Everyone's talking about it, and you hope sometimes. I think engineers are hopeful that this will catch on, and we won't have to change it again later, or there'll be a community around it so that, when there's a transition, it'll be graceful to some degree. I think Docker has been one of these things I'd be surprised if it went completely away. I mean, everyone in the WASM community, WebAssembly, I think they want to kill containers off. They talk about when I think about and look at the core of it, it is a sandbox kind of, or containerization technology. I mean, there's other aspects to it as well, but at its core, that's what it's bringing. And I think that's been around as long as I've been, almost as long, it feels like. Maybe not quite as long, but it's not a new kid on the block. So I think Docker has managed to kind of take up resonance in everybody's. It's kind of like Git in some way. I feel like it's there kind of in the background almost.
I definitely, I agree with that. I want to talk a little bit take a moment just to talk about the work you do at Contiamo. So for our listeners who aren't familiar, what sort of problems does your team focus on, and where does maintainability fit into that work?
So we are a data engineering, data science consultancy in Berlin, Germany. And primarily we work with large enterprises. So this is telecommunications, logistics, real estate. And we're very fortunate that we work with some very large, very successful companies. And so that presents some very interesting challenges in terms of especially maintainability, because these are large organizations and they are just incredibly diverse, both in terms of type of people you're talking to, the type of teams that you're working with, and their relationships to each other. There's politics, and not in the sense of like, oh, there's politics bad, politics big P or whatever. Like, it's just there's lots of people. There's naturally going to be, how do you collaborate together? People have different concerns, different purposes or goals, and trying to align things. So, and then we, especially focusing on data engineering, data science, of course, the AI topic that everyone wants a bit of, also makes that a little bit more challenging, because of course, everyone wants to do something with their data. And then you go, okay, well, let me see your data. And they go, no, you can't see our data. Or you need to go through many, loop or hoops in order to get to it. So maintainability in that context becomes a challenge. And I think our solution, or at least internally, our solution is everything we can write down as code. So infrastructure as code, processes as code, CI/CD, everything as much as we can into code, then we can hope that it's reproducible. So we can do it here in this, test environment, and then hopefully bring people through to, maybe we don't bring it to prod or their team brings it to prod. So there's a lot of communication that's involved with that to then bring some data engineering, data modeling, or AI projects into their production environment. So, and maybe that's why like the ability to read something. So on my side, that means writing a lot. Writing these things and trying to identify the parts that are the most complex, so that when someone else is looking at it, hopefully they go, this is big, or this is going, maybe the code isn't big, but it has a big impact, or they're hoping it's going to have a big impact. They weren't part of the whole process, but they can feel comfortable saying, okay, I think this should work, this will function, and it will deliver, that value that we're searching for. So, I mean, there's a mixture of kind of people I'm thinking about when you have engineers, you have DevOps engineers, you have data engineers, and then you also have the business side of all of this in a lot of these projects. So the big part is, what can we put in the code? Because hopefully that means code is, we can rerun it. And then what can we write down, document, or automate so that it's 2 instructions instead of 15 instructions that we can give them.
Now, in these types of client engagements, are you typically coming in and helping their internal engineering teams experiment with some new technology and or show them different ways of doing things? Are you building tools for them and then handing those typically over to your clients to maintain, or is it often continue maintaining them yourselves?
We have a diverse set of projects. So because, in terms of like our team, we have software engineers with kind of a interest in data. So we have data engineers, data scientists, and the ideal project is one where we can kind of take full ownership. And that's me as a software engineer saying, well, I want to do my stuff my way more than anything else. So it's like we can take ownership and then deliver final results and then coordinate with their team, because they're large enterprises, to put it into their cloud environment usually. So we're not usually hosting it. And then the ideal project would then result in them going, this is amazing, but wouldn't it be cool if it also did this? And so then they ask you for a round 2 and then a round 3, and, or version 2, version 3, version 4. So those are kind of like the ideal projects. And some of those can be demonstrations of technology, what could be possible. Some of them are much more, they know exactly what they want. And so they come in and say, you've done this before, or can you do this? And those will quickly grow and usually last quite a bit longer in terms of just total lifetime. And we'll do some maintenance, but it's definitely something that's more, it's like, okay, hopefully we deliver something that is sustainable enough that it's not like there's a beeper or alerts, not that type of maintenance, but more of, it's scaling, we're doing more because it was successful. And now what can we do? So it's more about growth than it is, this isn't, stable.
Sure. That resonates. I also, I run a consultancy, and so I could speak a little bit of this this realm. It's always interesting to talk shop with different people. I'm curious, as someone who's like heading up engineering there, and as you're involved in recruiting, I assume, of your engineers, is there something that you look for in those types of engineers, that knowing that you're in a client services business versus if you were, say, a product company? Do you feel like there's a distinction there about how you think about what you're looking for out of, especially if they're going to be potentially client facing?
I think there's the low hanging fruit, or the low hanging answer to that is simply communication. Obviously, there's going to be more expectations. I mean, there's communication in both roles. There's not, it's not to say that the one is more or another is less. But when you're coordinating or collaborating with a peer, there's a lot more flexibility to learn how to collaborate. When you're collaborating with someone who's paying you and could walk away from the table, that patience might be next to nothing. So there's definitely some expectations around kind of communication, but I don't think that we have ever specifically looked at and said, oh, this person is going to be bad talking to a client. Like, I'm not looking for a salesperson. It's not like, I have no idea, but I have this quote in my mind from like some movie that I saw once where it's like, sell me this pen or something. We're not looking for this sort of slick talk. Generally, what we're looking for is someone who is curious, open, because a lot of the biggest difficulties, there'll be some technical ones, but it's usually just getting an understanding of the other person you're talking to. So some empathy helps, but a general openness, curiosity. And I think this pays off not just with talking to clients, but also on the technical side, exploring new ideas, new projects. Oh, they're doing this. I wonder why they're doing that. Not, oh, I can't believe they're doing that. How ridiculous can they be? It's like, well, maybe there's a reason for this. Maybe there's something there that I need to understand. Maybe we can simplify. Maybe it doesn't have to be this way. Maybe it does have to be this way. But searching for that kind of curiosity and then pairing it with some kind of capability to communicate that in a way that is, graceful with the client.
We'll be back with our conversation with Lucas in just a moment. Hi, it's me, Robby. I just want to take a moment to say thank you for listening to Maintainable. If you're finding these conversations valuable, please consider sharing a link amongst your peers and/or writing a review on Apple Podcasts or Spotify to help spread the word. If you're not sure what to write when you're writing a review, just say, really enjoyed the conversation with Lucas. Robby should ask better questions. 2 stars, 5 stars. Be honest. But anyways, let's get back to our interview with Lucas Roesler. Out of curiosity, have you worked at product type organizations in the past and moved over to this, or have you primarily been in client services?
So Contiamo actually has a very interesting history of having started as a SaaS, your software as a service startup, trying to, become the next unicorn and, doing what most startups do. And you get to a point where you go, this isn't sustainable. And what can we do? And we had originally started, even before I joined, it had started as a business analytics tool platform, so hook your data in, see some graphs. And when I joined, we were trying to kind of be more of a data science platform, so more like where data scientists could do Jupyter notebooks sort of things. And ultimately, going through all of that, we're talking about kind of building platforms where people do stuff. And you're talking to enterprise organizations. So they're like, oh, yeah, we're interested in that. Oh, by the way, since you're here, have you ever done anything like this? Have you ever done anything? So we ended up having lots of kind of side projects going on, and we always envision it as like onboarding or an integrations process, not as a alternative. But so we were lucky though, because as this continued, we realized this isn't sustainable. So what can we do? So, there was a painful moment of, we did get a little smaller, but we said, could we just continue doing and focus on doing this consulting, especially more solution space. So it's still engineering. Most of the people that are doing engineering will hopefully be happy with that. But it's obviously quite different, clearly. And that was successful. So still here. And that happened right before COVID as well. Maybe there's a little luck with that. Everything went in chaos. But I think, so there was that moment. So that's one time in a product company, which was your question. And before that, I was at Team, which was previously Eventboard. And that was actually acquired by WeWork before getting spun. It has an interesting kind of like history there as well. And there I joined originally as an engineer, and kind of through its initial really big growth and worked my way up to director of engineering. And that was, of course, a product company where they were at its core I always forget the word that we were using. But if you've ever been in some of these like shared workspaces, they have usually like an iPad outside the office door. So you might have a shared space. And so you want to book the room and block it from someone else, or you want to book it from your phone or from your desk or whatever. So you have to synchronize calendars and synchronize all these devices. So they provided the software for those iPads, basically.
I'm curious, I'm going to pivot a little bit to talk a little bit about a story that you shared ahead of time. You mentioned inheriting a modernization project that was built on, I think, maybe 10 plus years worth of PostgreSQL views, triggers, store procedures, and materializations, and had absolutely maybe next to zero documentation. Can you walk us through a little bit of that story and what you encountered?
Yeah. So speaking of this transition period, this happened right in this transition from kind of being a product company to doing consulting. And so it was our first, maybe not first, but it was one of this is important and big. We got to make sure we do this well. And this particular client had a ton of data being synchronized from an application that, from my understanding, is like a custom built application from another team. And that also had like 10, 20 years of history in it. So they had the synchronization to Postgres, and they had a DBA who was responsible for this Postgres, and then they would keep asking him for more things. Postgres has to do more stuff. And it was functional, but at some point they said, okay, well, what if we wanted to have more history, or what if we wanted more? Just kept asking for more. And the answer was, well, you can't do this in that one Postgres server. Maybe you should look at like a cloud database like Snowflake, or any of the cloud providers have some similar sort of database that's designed for analytics. And so they said, yeah, let's modernize. Especially when you're talking to certain types of enterprises, you go, oh, modernize the cloud, like all the big players, and everyone gets really excited for it. And so it's like, okay, but it has to be the same. We need this same report. And so, but of course, since you're starting a new project, saying, well, we'll just copy all of those things again would be insanity, because especially for something that's as old as this, the context has changed. It doesn't mean that it was wrong or bad, just that, those decisions, we have a different context, different potential problems. So it's opportunity to kind of look with fresh eyes and say, okay, which of these things make sense or not? But I think we also come from kind of going back to this question of maintainability. We like things that we can put in code. It's easy to say that, here we've delivered a project. Here's the code to this project, in addition to something that's running. And here's the code to get it running. So it's very easy to point at, here's the deliverable, you have this thing now. And so looking at a project like this, okay, you have all of these really important reports, they're in a database, and looking at kind of our background, that meant that we wanted to use stuff like DBT. This is, especially at the time, very popular for how do you create a repeatable software project around SQL. So there's a lot of things about data engineering, or at least traditionally, that feel very different than if you're writing Python, Ruby, Go, and building a web service. Just
what's DBT by chance?
So DBT is a project out of Pennsylvania. I'm trying to remember. I mean, DBT is I think that's just the name of the company, DBT. And at its very core is it's a Jinja templating language for SQL. And then you have a CLI that will allow you to transform or like plug in to that template so that it applies to, I have a local database, or I have a dev database, and I have the prod database. And it will then do other things, like, because you have this templating in it, it has a bunch of templating functions that connect all these different SQL files together. So now you can actually say, oh, this file is related to that file. If you've ever used IDE in any kind of scripting, or, let's take Python or JavaScript or Ruby, you go in, you click on the function, jump to function, and you can kind of do that when you have stuff like DBT, because now you have it actually tracks these relationships. So especially when DBT first came out, and you said, oh, well, what's the relationship or the lineage of my data? It was one of the few tools that you could just reach for that was open source, or it's open core. So as a core open source product, and then as a cloud service that's wrapped around it, and provided a reproducible, put it into Git, give it a software lifecycle that people are more familiar with, make it testable because you can run it in different environments. It even has its own concept of data test and unit test, which if you just write plain SQL, like the idea that you could write a unit test for it, I'm sure that someone with even more experience into DBA world would say, oh no, there's a way to do it. But this, if you're coming from the software world, it just feels very natural in many ways. It has its shortcomings, and they have new versions coming out that will alleviate some of those. But if it's just a bunch of files, just a bunch of SQL files with no connection to each other than some made up rules that, as you've developed it over time, it's definitely a really big improvement. So this is something we like to do, like to use when we're doing SQL, because we really haven't found a great alternative that provides that same sort of like, okay, let's create something that is kind of, that helps us think more like software engineers as we're doing all this. So we said, okay, let's do cloud develop DB, let's do DBT. Now you get all the special, so going back to the project, it's like, let's modernize your data stack. And so then the final step is, of course, what are we modernizing? So you finally get access to a copy of this database, and you look at it and you're like, okay, here's a table. Oh, it's a view. And then you start looking at it and you go, okay, how many tables are there? And it's thousands of tables. All of a sudden, you're just like, even 1,000 tables would be a lot for a person, and it's even more. And so we're just kind of like digging through it, and we're like, okay, who did this? And we're like, so we started having some conversations, and ultimately one of the good things is that Postgres has a lot of metadata. So, for a short time, me and a colleague were very good at all the metadata information schema tables inside Postgres, because it's like, okay, this information, most of it's there, because if you've ever done a lot of stuff in a database and you've used views or materialized views, you know that it knows Postgres will complain if you start changing things in bad ways. So it's like, okay, the information's there. How can we get this? So, I think it was just a month of exploring every single information schema table and the relationships between all the other tables in the database, and then creating a script that would allow us to kind of extract some of that information. This table is related to that table, which is coming, there was this function that helped, create this table. So a lot of just grunt work for the, I don't have a better word for it other than, okay, you pull up the sleeves and you just dig in.
I'm curious if you recall some of the reasons why a database would ever have thousands of database tables. Is it as simple as like they had that many different, they needed to isolate data for different specific clients, or they have like customer specific tables, or just like things of that nature? Was there a lot of like namespaces that they were using there for things like multi-tenant, and just like a lot of the same tables, but just...
So in this case, it's single tenant. And I think there are two main drivers. One is age. Simple. This is a 20 plus year old, like the original source of data is like 20 plus years old at this point. It's like, I just read something about the .com crash. And it's like, this database is as old as, pets.com was, basically. So, okay, there's lots of things that are going to happen. And thinking, as you were asking earlier, you were there, were you there when we moved from monolith to, distributed systems and back, or, these sort of things. And this stuff happens, of course, at the data layer too, like the databases. We should be more normalized, less normalized, document focused, et cetera. And so this database kind of showed some of that history of, you can see little things here and there. This one is where they wanted to be more like this. This is where they wanted to do a little bit more like that. And I think also as a whole community, and software engineering as a whole, like there's been a lot learned over that time. So usually we learn things the hard way because we did stuff, we survived it, and we said, let's not do that again. Let's do it a little bit different the next time. But that usually leaves something behind, in this case, this database. So there was it was incredibly normalized. And the second thing, related to the normalization was that they had a lot of customization and localization. So they wanted things in English and German. And so you want everything, like they had so many things that were custom. And then everything that was custom had to be twice, or like had twice as many fields sometimes. So it depends. Sometimes you had twice the tables, and sometimes you had twice the data fields or columns. So, and then knowing which one you were going to get was always a little bit of, well, how old was this? And then you would usually you could figure out kind of like, oh, there was a period of time where everything was 2 tables, and then they said, no, this is not what we wanted to do. And so now you have a lot of leftover stuff in a database because I guess you could clean it up. I think I would clean it up, but they have other stuff to do, other priorities, hopefully making money, I guess.
I want to pivot back to earlier, you touched on observability and feedback loops in general, I think when we're thinking about our software and our systems. So I know you put a lot of emphasis on, say, creating fast and clear feedback channels through things like logs and metrics and tracing. So why do you think teams tend to treat feedback as optional instead of an essential thing?
Logging, you can see people will reach for it much more quickly because it's easy. I think with metrics and tracing, you need to add in a new component. And being the person to say, let's add a new component, some people are really excited by that, and some people are maybe less excited to do that. So yeah, you might have to run it and keep it running.
Logs are seemingly, I think it just seems like for me, like logs just seem like they're just there, right? They're like, they get spit out. So it's like, well, I guess we'll send them over here. Logging is almost free. But I think when you get in.
And metrics is a lot like, I feel like data engineering. If you want to add metrics, really good metrics, they've been designed. They don't just happen by accident. And because if you just do every metric by accident, it becomes like this overwhelming list of, well, how do I put these things together? So it has to be kind of designed with some sort of schema almost at the beginning to make it really good, which can be quite intimidating. So someone's be like, oh, well, do we really need to add this metric or do we not need, like sometimes maybe you have some architect or someone else someplace, me saying, hey, can we be simpler? How can we keep it simple? And so I think sometimes adding these other layers can look like complexity, where often the complexity is probably worth it, especially if you really have to keep a system running especially if I'm ever on call again and I had an application without some amount of metrics and tracing, it would probably be the first thing. It would be like a weekend, like, okay, I'm gonna just do this. I need this because there's no way if something pages me and I need to like interrupt something else and there's no information to go on, that's a nightmare. Wake up in sweats because, sort of thing. So I think for a lot of teams, it's adding something and it looks different. A lot of times I guess sometimes it depends on the language. Doing a lot more Python recently, and that means that you can kind of monkey patch it on the fly, or it's much easier to just like throw in additional libraries or have them mutate kind of, I'm adding some tracing and I want to change the API client, so I can automatically add traces without changing the rest of the code. But when I was writing a lot of Go, this is much harder to do. And so saying, hey, let's add traces to everything. And if you are unfortunate and haven't added, in the Go world, they have this variable called context. And usually this is where tracing kind of information happens. And so all of a sudden you're saying, oh, all of our functions, you have this context variable. We got to change all of our functions. And then also that's not enough. You got to then add more information inside. And that information is valuable. And the automatic tracing sometimes isn't as helpful. Doing it by hand, where you said, oh, this information is important. If a person has put that in there, it's probably a much better signal than just random machine said, hey, this should be added in. But that's a process. It takes a lot of effort. And you got to then stand up and say, this is worth it. People still kind of debate. I think there's a overhead to tracing and whether or not it's worth it. It's not enough. I've never seen an application suffer because of tracing. But then you'll see someone who's really passionate about performance come in and be like, oh, there's this much overhead, some percentage. And so then you go, well, is it worth it? Is it not? I haven't worked on like high speed stock trading applications where milliseconds of performance are going to make the difference. So maybe I have that luxury of saying, oh, I have time. I have milliseconds I can spare.
What sort of other, aside from like say that overhead, regardless of how big or insignificant it might actually be, what other hesitations do you still hear from teams or from clients about introducing something like, say, OpenTelemetry into their applications?
The answer is still time. which is a kind of performance, but more for the human side of things, of priorities. And it's easy to build an app without telemetry. So there is some inertia, no matter what you do. So as I mentioned, with some of the applications, it's easy to just kind of add default telemetry in. So you can kind of start with something. And if you can do that, then I would usually advocate, it's like, look, if you can do this in 1 hour and get this out, at least you have it, you can turn it on. It's going to add some operational complexity. You have to pick a vendor, so sometimes you're like, oh, like who are we going to pay to receive our telemetry data? With logs, like you said, they're just there. In almost every system that you've ever deployed on, they're going to have some concept of, here are some logs. Now what do you want us to do with them? And the default is, well, you can look at these as long as that service is running. We'll keep the history for one instance. And if you want more, then you can pay for more. But usually, a lot of times it's like you click a button. Adding telemetry is not click a button usually. Or when it is click a button, it's a button with a lot of dollar signs next to it. And a lot of software engineers don't have that option to say, oh, let's spend more money. Or, in my world, it's go tell the client, please spend more money, above this default, unless we build it in at the beginning of the conversation, saying we recommend, so if you can get that conversation started saying this is valuable, and this is where people having experience with it, battle stories can be like, look, this will save so much time that it will pay for itself.
I think it ends up being one of those weird things where it's like, it's a maybe a slightly different new paradigm. I think a lot of developers, myself included, can kind of get an idea of how I think that could be used in like a debugging situation. But until you've actually maybe done it, you don't really necessarily know, like, well, information's there. Maybe one day I'll be able to use this and I can click through and find things. And like, until you have that aha moment, you're kind of like, well, I don't really know what are we doing here? What sort of information? What does good observability look like? Am I collecting too much information? Is it too much noise? How much am I going to spend on that? How much do I really need? I only need it when I need it, type of thing. All the different like excuses that we have for why we won't spend money or prioritize something, because it's not just the money, it's the time to focus on it and knowing like, well, what's the best way to go about doing this? And not everybody has been trained on that or spent the time to really, watch more than like a quick YouTube video or something. So it's a challenge, I think, for teams to kind of wrap their head around like what that looks like, unless more people show how we're actually doing this. And sometimes the people that are doing it successfully or can't show you because they're looking at confidential data, right? And so, what are you going to do? And try to come up with some like weird little demo examples that aren't often complex enough to really wrap your head around how this is helpful in really complex situations. Like, well, I don't need that. I can just do that in the logs.
Yeah, you can often get away with stuff in the logs, but I've sometimes found tracing just adds a visual component that sometimes humans are really good at recognizing those patterns that you wouldn't see on the terminal in a log. Unless you structured your logs in just the right way, maybe you would notice it. But because I've used it not only in production, obviously in production, but even just local development. One of the really nice things with OpenTelemetry is that so many of the providers, not the vendors, right? So whether that's Amazon or the one I like to usually go to first is Grafana, so you can pay them to be this, where you put all your telemetry. But the nice thing with Grafana is they actually have a nice single container. So if you're like me and you create projects and you have a Docker Compose in there, you can add one more service and then have telemetry that opens up in a nice visual way. And you can do it all the telemetry, metrics, logging, tracing, all in that one little. And it doesn't cost anything to do it locally, but it can very quickly see, I thought that I was doing stuff in parallel, but now actually it's a cascading request to my database, sequential cascading requests, this waterfall of work that's happening. I don't like that. That's definitely not good. And if you were just looking at the logs, you probably wouldn't notice it, especially if it were fast enough, especially locally. But you would immediately see it because it just stands out dramatically inside of a trace. And that's the easiest stuff where it's like, there's a very visual pattern. And you can do this without necessarily spending more money. And if you're fortunate and you're using kind of like really popular libraries, you might be able to just plug it in a couple minutes. There might be install OpenTelemetry. I use Fast API, OpenTelemetry, Fast API, OpenTelemetry, SQL Alchemy. Like you might even, and then you add like 2 more lines. And now you can see, oh, that API call came in and it made all these database requests, and that pattern, that looks weird. Why did that happen? And you can start answering these questions. And that can be kind of your foot into the door. And then you can maybe add a little more and be like, oh, what's happening there? And then you can decide to put more effort in.
Hey folks, it's Robby here. We recently heard from a freelance developer. They'd been working with one client for years, nights, weekends, fitting things in where they could, but now they're ready for a full-time role again. So what do? They introduced their client to us, Planet Argon, because they wanted to leave the app in good hands. In that moment, it means a lot. It's vulnerable. They told us that they felt guilty, that there wasn't time for doing a lot of automated testing or adding a lot of documentation or even handling some of those long overdue upgrades. They felt really guilty about it. And they worried that the handoff would be really messy and that we would just complain about what they had handed over to us. But here's the thing. The client thought the world of them, and they were grateful for everything that developer had been building for them. This happens a lot more than you think, and when it does, we don't show up with judgment. We show up to carry the torch, to help the app take its next step, to honor the work that's already been done, because we get it, and we're good at this part. PlanetArgon.com, that's PlanetArgon.com. All right, let's get back to the show. I want to get some advice for our audience here. So if there's anyone listening out there, and it sounds like you just brought up a good use case there. If someone was interested in, say, using something like OpenTelemetry but they didn't really feel like their team had a lot of buy-in at the moment, like their peers, let alone like, say, I'm air quoting, a stakeholder or someone that has some say over what they aren't going to implement. Is there like a way you would encourage people to maybe approach their peers on getting a little bit of buy-in on that idea about maybe like a small experiment that you can run together, or just even be able to use it locally without getting permission to do so before you go show off to other people?
Yeah, that's definitely tricky, because I think where you can convince people the most is probably the hardest thing to manufacture, which is, I solved the problem that someone else couldn't solve. So this could be something like I mentioned, you have a local project there, and like I said, if you're fortunate enough that you don't have to put in and change all your code, right? So you can kind of like put it in, then this might be a way to debug something that I think some people, I remember, I'm not one of them. I've never really gotten good with the debugger. And this might be the thing that they would use instead, where it's like, what is going on inside this program? Well, let's run the program and then tell it, or have it tell me what's there, what's that value, then wait, and then tell me the next value, then wait, or any of these sort of things. I never got good with it. I just, for whatever reason. And I think telemetry is an alternative to something that's very similar. What happened right there? Run it and see what is happening. And I feel like it's very similar to what you're already doing as an engineer, writing software. You're writing this code. Well, let's put one more line of code in, and as opposed to doing something new. Not that a debugger is not software engineering, just that it's different than writing a line of code, right in the code. Much like logging, you run more line in the logs. So I think that's probably the simplest way is, you can take, as I mentioned, Grafana has one. I'm pretty sure there's a few others, but that's the one I kind of reach for first. And the nice thing for most people is that now you can use OpenTelemetry and you can say, look, we can use this. We can turn it off, no impact, if that's what you're worried about. And then if you have examples where, I was able to make this better because of this telemetry, or there was a bug, we couldn't reproduce it. So now we did this, and then we had some insight because we were, you notice a pattern and say, well, that could be a moment there. It looks like those two functions they have a relationship that maybe wasn't obvious. Why did that get called again? Actually, this happened just recently, and I still haven't found out what's going on in another project where I was like, what's going on? So I started putting in more and more. I said, I need more information here. And I added one more line so I could see that thing. And now all of a sudden I know that this function is being called twice. I need to collaborate. It's an open source project. It's a bug in an open source project. So I don't want to make the project sound bad, being like, hey, these people have a bug, but I'm coordinating with them now. But now I can say, hey, this is definitely happening without any doubt. And here's where it is. You can see it, and you can share like a screenshot, and it's immediately understandable. And that has nothing to do with prod. So if you have sometimes you have stuff like that where you're like, I don't know, something's happening in there. Well, what's happening in there? And you can, instead of trying to guess, if you don't know, logging, you have to put a line somewhere And so what are you going to do is put a line everywhere? Tracing kind of maybe you can do something where that happens automatically and then you get it out of the box and maybe see something more quickly. So you can do it locally, debug something that maybe it's expensive to do in production because it's, makes a call to the credit card company. You don't want to just repeat that. So now you can try it locally, see what's happening, and actually see it actually behaving as opposed to, well, I think it's doing this, I think it's doing that. That's where I would start. I would say, try it locally, show someone.
No, I think those are some really good examples for listeners to kind of explore how they can potentially use something like OpenTelemetry in their projects and with their teams. So thanks for that. Thanks for digging into that. So I have a couple of quick last questions for you, Lucas, because I've held you long enough. First of all, is there a non-software, non-technical book that you find yourself recommending to peers very often?
It's tough because I think I always want to try and recommend based on the person a little bit. The thing I'm reading right now, which is not a deep cut or anything like this, is The Wheel of Time. When I was younger, I had stopped reading it. And then, of course, the TV series re-sparked the interest. So I'm making my way back through that. And it was, for some reason, it had gotten stuck in my head that, maybe it's a little overrated or everyone, it's a big book series. I think a lot of people that if you read fantasy, they know of it. But then I was reading through it, I was like, no, it's a good reason. There's a good reason people like this and people have recommended it in the past. So I've really enjoyed it. So if you like science, I like pretty much everything by Charles Stross. So the one that stands out in my mind is Accelerando, which is actually originally, I think it was kind of a couple novellas put together. And that one, I think when I read it, it was the first, I've read some stuff where things happen in the future, but this is one that kind of like stepped through really big leaps and kind of forced you to think about, it's like, what would that do? Or how would these changes happen? And then like, there's a big leap. Let's imagine now that you've had 100 years of that or more. And just like really crazy ideas that he proposed. And of course, it's I think there's some people that have read it and look at it and go like, this is cool. We should reproduce all of it. And it's a kind of classic. Not everything in here is meant as an endorsement. He's like, please don't reproduce everything from my book. It's not a dystopia. It's not, but it's also not a utopia, people. You're supposed to think about it first. So that one I really enjoy and think about a lot, actually. I haven't read it in the last couple of years, but it still comes up. It pops in my head very quickly.
Nice. I actually hadn't heard. I think another guest or two have mentioned at Wheel of Time, but Accelerando I've not heard of before. So maybe I'll put that on my own reading list.
You have to like sci-fi for sure. Like it's definitely like if you're a person who's like, maybe not on sci-fi, then it's probably not going to be your favorite thing. But if you're into it, then I think you can enjoy it for sure.
I'm trying to be more open to it. I don't know, for whatever reason. I think for a long time, reading for me was like when it came to fiction things, it was hard for me to get over the hurdle of like, is this productive or not? And then what types of fiction resonated with me. But earlier this year, I read Project Hail Mary actually, and based off of a guest on a couple guests had mentioned it, and I loved it. And then I was like, all right, I'm gonna read some other things. But I'm gonna try to check. I'm gonna check out Accelerando. I think that's I'm looking for a new book to read in the next month. So I might check that out. So thank you for the recommendation. And where can listeners best follow your thoughts and ruminations about software engineering online? Do you blog or anything like that?
I mean, technically there is a blog at lucasroesler.com. It's pretty stale, I think. And, they do have like Blue Sky and Mastodon are places that I exist. But I find myself trying to listen more these days than writing as much. So I guess at a conference in the hallway. Because I definitely think I'm a loud speaker. Like I'll definitely be like, I have ideas and I'll share them willingly, but I try to read and listen a bit more these days.
Nice. All right. Well, I'll definitely include links to those in the show notes for people, and maybe one day someone will come across something new by you. Or you can talk about the new podcast episode that you were recently on. So there you go. Well, thank you so much for that, Lucas. Thank you so much for stopping by to talk shop with us on Maintainable today. Thank you for having me. I really enjoyed it. You've been listening to Maintainable, a Planet Argon production. Editing by Claudia Armbruster. Post-production by Auden Morgan and Ellis Fenson. Emotional support from the letter M. For Maintainable, for momentum, for making things better. If this episode resonated with you, share it with someone who needs to hear it. Keep showing up. See you next time. maintainability.